welcome back. This is Shrikant again. This is a day 7 of our series, that is Learn SQL Server in 60 days. So today we will be seeing a very important concept in SQL Server, which is normalization. Basically, this is a database concept and which is very important to know while designing the database, right? So we store data in a table just to have a data whenever we require, but sometimes what happen, we store a data in a such a way that data get redundant. So what does it mean, data get redundant? So data get redundant means the data get repeated. So block of data get repeated. Okay, so today I'll be covering following points and I'll be going through one by one. So the first thing which I'm going to talk about is normalization. And what is normalization? We have just talked about it. Normalization is process. It is the process of removing or minimizing the redundancy. It is the process of minimizing data redundancy. Just to note, it is not the process of removing the data, it's a process of minimizing the data redundancy. Okay, so it means we don't need to have a duplicate data everywhere. So this is about the normalization. So why do we need a normalization? Why do we need, first of all, we need normalization to avoid the anomalies, like insert anomalies, delete anomalies. Third one is update anomalies. If data is repeated a lot of places, so it would be a very difficult to update all the data and to have the consistency. Sometimes what happen, we update the data but we forget to update the data at one place, right? So to avoid such a kind of thing, we go for the normalization, right? Just to repeat, why do we go for normalization? To avoid the anomalies. Which anomalies? Delete, insert and update. Next, so there was a scientist who has given the normalization, who derived the different form of normalization. His name was Edgar Codd. Who designed normalization. It may be interview question also. So there are a lot of normalization form we have. We will go one by one. So first normalization will be talking now. So before that, I will be giving you a rough data structure of my existing table. So I have the column like a person name, then his address, then movie watch, then salutation, great. So these are the column which I have. Let me repeat one: person name, address, movie watch and salutation. I am trying to make a very simple explanation with respect to normalization, so I am just taking only 4 columns so that it will be very easy to understand the normalization concept, right? So these are the columns which I have, and it has the data like person name is Shrikant, then address Nagpur, India. Movies watch. I watched the movie A, then B, then C, then D. 4 movie I watch. Salutation is Mr. because I'm a male. Let's add one more entry or leave it. We'll go with the simple example. So this is the data, this is the raw data I have, and I want to make this data in a such a way that it follows the normalization rules. Okay, let me once again talk about this data. So I have a person column here, name is Shrika, address column, here I have given address, and here you can see these are the movies watched. So I have watched 4 movies, A, B, C, D, and my salutation is Mr. Okay, so let's move to the first normalization form. To make the data in a first normalization form, it needs to follow 2 rules. Which are those 2 rules? So rules are: each table cell should contain a single value. Each table cell, here we call it as a cell, right? So each table cell should contain the single value. This is the rule 1. And rule 2 is each record needs to be unique, and the record, this is called as the record, right? So each record should be unique. So if I want to make this table is in a first normalization, I can make like this. I can copy these names. The first rule is the data should not be comma separated, right? So these things are not comma separated, but movies watched part is a comma separated, so I can make it a single row. Right? These 3 columns will be repeated. Data. Great. So this table is in the first normalization. Why it is in a first normalization? First of all, because it follows all the rules which are required to follow to be a table in a first normalization. So each column has a single unique rows, right? It has a single value for each column and the unique rows here. Here you can see these are all the unique columns. So our database is in the first normalization. Great. Next we'll talk about keys. The column which are required to form a uniqueness in a table, those columns are called as the key column. The columns which we can say are used to define the uniqueness of a table, then those columns are called as a key column, and the columns which doesn't have any uniqueness or which doesn't define uniqueness of a table, those columns are called as a secondary column or non-key column. So these are the keys column which define the uniqueness of columns, and the non-key column, the column which are not a keys column. Great. Next we know about primary key and the foreign key and secondary key. Let's talk about the primary key. So primary key is a key which is used to define the unique value for a record. So each value in a primary column will define the uniqueness of a row. So that is called as a primary key, right? So let's move to the second normalization now. If any table want to be in a second normalization, then it needs to be follow following rule. So the first rule is it should be in a first normalization, that is it should follow all the first normalization rules. Also second rule it needs to be follow, and the rule is single column primary key, and the table should have a single column primary key. it should not have a composite primary key. The table should have a single key, which is a primary key. Great. Now this is my table which is in the first normalization. Now I want to make this table into the second normalization. How can I do that? So I can see here person, address and salutation. These columns are related with a person information, right? So let's copy and make this as a one table. And movies watched are not related with the, yeah, these are related obviously, but these are not directly related with the person information, the personal detail. So you can make this column like this and rearrange it. So the column which are labeled, these are, you can create a second table for that. Here the very interesting thing is that these are the personal information. So add one new column called as a primary key. Let's say member ID or person ID. So I am adding it as a 1. Two, three, 4. So these are the values for this is the newly added column for the personal information, right? So if you carefully see this, all this data are repeated. So I am having only one person, so I can make like this and I can name this table as the person information, person detail. Next, movie watched. This person I can write like this. So person ID is a foreign key for this. So person ID is 1 1 1 and 1. And we can also add one more watch detail column to uniquely identify this table. Watch detail 1 2 3. So this is watch detail ID. This is person. So person 1 has watched these 4 movies. So I can write like this. Great. So these are the two tables which we have created. We can name as the movie watch. Person watch detail. Great. So we have separated one table into two tables, right? This is my one table and this is my another table. So here you will see the person ID here and the person ID here, both are the same. So basically this is the primary key column and this is the foreign key column for this table. Great. Now this table, it is in a second normal form. So we have separated this data into the first normalization, second normalization. Now let's talk about the very important and the some interesting thing. So what is foreign key? As we know, foreign key is a key which defines relationship between the two tables, between the parent and the child table. Next thing we'll talk about transitive functional dependency. A transitive functional dependency is when changing a non-key column might cause any of other non-key column to change. What does it mean? So the non-key column what does it mean? It means that if we change a non-key column, and if that non-key column is changing other non-keys column, then that situation is called as a transitive functional dependency. If I am changing a non-key column and that non-key column changing another non-key column, that time the functional dependency is called as the transitive functional dependency, because that is dependent, right? So let's say in this example, if I am changing the name of a person, so salutation should also change, right? So I can make another label, so that I can make another table there where I can have the salutation part, right? So this is called as a transit. Let's talk about the third normalization. So what is third normalization? Third normalization having a following rule. It should follow the second normalization, that is, it should also follow the first normalization, and has no transitive functional dependency. It means that if I change any non-key column, so other non-key column should not change. That is the rule for this, right? So if I want to make this table into the second normalization, how could I do that? For making it into the third normal form, I need to create another table for salutation. Here I might have salutation, but that will be ID. Right, so this table will be as it is. Now we are adding a new table called as a salutation ID and salutation. Here we can add Mr. salutation ID 1. Like that. We can add 2 also. And so here the salutation is a primary key column, salutation ID basically, and here in the table 1 it is working as the foreign key. So we have created this new table salutation, and we had this table, so we can easily derive how many movie has been watched by a person by having the data in a third normalization. We can also tell how many movie has been watched by this person by the first by the raw data. We can also tell how many movies has been watched by this person by the first normalization. We can also tell how many movie watched by a person in the second normalization. We can also tell in the third normalization. So it depends on you which normalization model fits into your organization, and which is good for your architecture design. So this is all about the third normalization. Next is BCNF, Boyce Codd normalization. So after applying the third normalization, sometime what happen, a database is not in a normalization form, so again it need to be further divided. And when it arises, when for example if a table is having a multiple candidate key, that time BCNF come into the picture. So what is the candidate key? So let me talk about, if I have one table and if there are a lot of combination which define the primary and which define the uniqueness of a table, then those columns or those keys are called as the candidate key. It is the all possible combination of keys which define the uniqueness of a table, right? So any one key can be a primary key from a candidate key. So that is the basic difference. If there are a multiple candidate key, then we need to go for the BCNF. So this was all about the normalization. Hope you understood the concept of normalization, and if you like our video regarding it, thanks for watching.